This is Algebra Lesson 6.2, Writing a Linear Equation to Fit Data. A line of fit is a tool used to model a set of data. A line of fit shows the general direction of the data and has about the same number of data points above and below it. Okay, so if we have a scatter plot and we wanted to write a linear equation to fit that data, we need to make sure of two things. The line that we draw needs to follow the general direction of the points, and it also needs to go in the middle of the points. So that would be a pretty good line. Some examples of bad lines. Okay, so if I have a line going maybe right here, it's in the middle. I have half on one side, half on another side, but it's going the wrong direction. And maybe a line right here would be a bad line. It's going the right direction, but it's not in the middle of the points. So it needs to go the right direction and kind of be in the middle. Same number above and below. To write an equation for a line of fit, we need two things. Our equations are going to be in y equals mx plus b form, or a y equals a plus bx form. Now these are really the same thing. Depending on how you may have experienced this before, our slope is always the number that is in front of the x. The intercept is the starting number. So whatever variables you want to use for it, the slope goes with the x, and the b, or the constant, the lone number, is the starting number. Okay, so we need our slope formula from yesterday also. Maybe I'll just write that one. y2 minus y1 on the top, x2 minus x1 on the bottom. I'm going to stick with this format. So this is my slope, and then my intercept, or my starting value, I can find on my y-axis. Okay, first example shows me some data, and it has a graph of that data. Sketch a line of fit of the scatter plot, and so I want to make sure my line goes in the middle of the points, and it should be pretty straight. That was not very straight. Try again. Close enough. So if I want to get a line of fit for this, an equation for this line, I need the slope, and then I need the intercept. So for the slope first, I want to label some points. I'm going to take my lowest x value and call that x1, and then with it is y1. I'm going to look for my highest x value and call that x2, and then with it is y2. So I could do my slope, rise over run. I can use these coordinates in the formula. I'm going to go 96 as x as a y2 minus 9 as y1, and on the denominator 40 as x2 and 3.5 as x1. On the numerator, 96 minus 9 is 87. And on the denominator, 40 minus 3.5, that is 36.5. So then my slope is 2.38. If I follow this line to the y-axis, I can find my y-intercept, and in this case it's 0, since the graph goes right through the 0. So I will write my linear equation, y equals mx plus b, and since b is just 0, I'm really just going to leave that off. So y equals 2.38x is my linear equation. I can use that equation to answer some questions. Predict the total fat in a burger with 20 grams of saturated fat. Since saturated fat belongs in my x variable, I'm going to put this 20 in for the x of the equation. 2.38 times 20 and I get 47.6. Predict the saturated fat in a burger with 30 grams of total fat. Total fat belongs in my y variable, so I'm going to put the 30 in for the y. So to solve this, I need to divide both sides of the equation by 2.38. And then x is 30 divided by 2.38, 12.6. grams. One more equation using a graph here. To quickly write the equation for that line, we need the slope, and then we need the intercept. So the slope here is rise 2 and run 5. So the slope in this one is 0.4. My intercept is where the line crosses the x-axis, and it looks like it's just above -3. I'm going to estimate it to be -2.8. So my equation here is y equals 0.4x minus 2.8. That is it for the examples. Good luck on the exercises, and please let me know if you have any questions.